Good morning, Ignite. There's a little bit of echo here. A lot of echo here. That's kind of cool. We'll play with that a little bit. We're here to talk about security, and we're here to talk about security on the endpoints. And I want to preface and say the word security a couple more times because I like to react in real time to the feedback that you guys provide on the session and the content that we're talking about. And I'm looking through the session reviews for yesterday, and it's all like, this is not at all what I expected. Why was this guy talking about security the entire time? And I was like, why was I talking about security in my Windows Security Internals talk? Would have thought that was expected. And then I noticed that the event team, for whatever reason, removed the word security from the description that everyone saw. And therefore, just like Windows Creators Update, deep dive. And that was it. So to be clear, we're going to talk about security in this session. If you do not care about security, you should find another session that's less security focused. If you do care about security, and you should, you're in the right place. Fair? There we go. Now, in terms of which aspects of security, this is a conversation that I have with a lot of folks who are trying to figure out what's the way forward. I want to be relevant today, but I want to think about where we're going. And a lot of today's security conversations are about how do I lock down my data center? How do I lock down my on-premises Active Directory and my on-premises SQL Server and my on-premises mailboxes and blah, 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 where the entire industry is basically trying to remove the on-premises from everything and everything's kind of going cloudy. Not that that's, directly to public cloud in every case, but to the cloud concept and frame of mind, whether that be Azure Stack in my data center or even just virtualizing the existing thing, I need to start thinking cloud-wise. We're not talking about that here. Also, to be clear, there's lots of great conversations on that here as well. The side of the fence that I'm talking about is no matter what servers and services you're connecting to, you've got to have an endpoint. I don't care if that endpoint has a mouse and keyboard, if that endpoint is voice activated, if that endpoint is goggles you wear around and look kind of like a dork, right? Whatever the endpoint is, you always have one. And we ignore that to our peril. If you think about whatever line of work you're in, there are some people in your organization whose information is sufficiently valuable that an adversary does not need to go and gain full admin rights. They could be a standard user on everything, no privilege anywhere, and yet they have the secret recipe to Coca-Cola. If you get on that device, you've got the goods you want. So we've got to get smarter about protecting the endpoint. And that's what I want to talk about, not just the simplistic angle of, you know what you should do, just do Windows 10 and endpoint done. But rather, well, that is part of it. We will talk about that. But it's not the end of it. How do I get there, and how do I really constrain it and lock it down, but do so in a way that's practical? Our goal is to make it as easy as possible to do the right thing and as hard as possible to do the wrong thing. Now, the title screen that was on the deck, which also didn't show up in the guide, but we talked about securing Tier 2, I just want to disambiguate that for those who aren't familiar with the tier model. The tier model is something that we use. It's a taxonomy that in essence helps you categorize the average value or expected value of a device. Tier 0, that's the tier that contains control over identity. If you have privileged access in Tier 0, you can be anybody else. Also, typically, that gives you a roadmap to all of the interesting people and who they are. So we spend a lot of effort in securing identity. The second tier, Tier 1, servers and services, whether they be cloud services, on-premise services, a server itself as a unit. Tier 2 is the workstation. That's where I actually sit down at a keyboard and do my work. Now, how this helps us is to think through what's the average value of this device, how should I be focusing and prioritizing my attention. If I have one single identity that has privilege in tier 0, I have everything else. So obviously, pretty critical. Let's look after that. An average tier 1 device is more valuable than an average tier 2 device for a couple of reasons. The average tier 1 device, there's usually fewer of them. Most organizations, though not all, have fewer servers than workstations. And if you're an adversary, our adversaries are human like us, and that means they are lazy like us. If you have a choice, I'd like to gather some of your proprietary business data. I can either go into your SQL Server database and do a dump table and gather all of it with a language that I know, or I can try to reverse engineer that crap Delphi app written in 1998 that, yes, we're still using. I'm going to opt for the SQL Server route because it's easier. So the average value tends to be higher than tier 2. Nonetheless, tier 2 is what interacts with the bad guys all the time. So we want to think holistically and make sure we get down and explore controlling and securing tier 2. So what I want to propose today is a roadmap that walks through 3 key areas where we could do better, typically, at securing my endpoints. Central to it all is, how do I harden those devices better? How do I get them to the point where they are more resilient to attack and I can get better detection? Ancillary to that is, how do I differentially protect my high-value assets and how do I support them? Which is something I don't think we spent enough time thinking about, and I'm going to pose a potential solution as part of our talk today. How do we harden it, support it, and differentially protect our most important ones? Now, as we think through device scenarios, this is where things start to get complicated. It's not as simple as one device, one configuration. We have loads of configurations today. Everything from, I showed up with my brand new Android device today. By the way, did you guys see the news that Bill Gates now runs an Android phone? Yeah, even Bill Gates doesn't run Windows Phone anymore. So we have the bring your own. Do you have a Windows Phone? Oh, that's awesome. Okay, the last 2 of them. The last 2 are in the room. Now there's it's like a rock concert now. Everyone's waving their Windows phones with the lighter app on it. There we go. It's not actually. My wife had a pride from her screaming hands. She loved the Windows Phone. But yeah, this bring your own device concept. Show up with whatever you want and connect, and let's help you be productive anywhere. Why do we like that? Because people work for free. Who doesn't want that? If you're a boss. Oh, you want to work on the weekend? Cool. Let me light up that device that you're carrying with you. We're not really going to talk about that here. It's important to have a BYOD strategy and lock it down. We really want to talk more of the high-value assets, further down to the right-hand side, really beginning at where am I managing the device, all the way up to the highest security scenarios where I need differential protection. So it's kind of baseline on the devices we're going to talk about, and I'm going to propose a life cycle that's iterative. Right? Because with so many endpoints, what probably is going to make it harder is if you try to go after everything all at one time. I'm just going to wait until I get everything perfectly engineered, and I'm going to have a heck of a weekend. Everyone's going to stay up all night long, and we're going to blast it to everybody. If instead we take a step back and start to identify scenarios, complete the scenario, deploy, move on to the next scenario, complete it, deploy, move on to the next scenario, we tend to see bigger success rates, right? It goes all the way from inception to the end. And I say the inception thing because that's an important one that gets ignored. But from roughly 2006 to 2012, I owned enterprise application compatibility for Windows, right? So whatever old stuff you had, like I would sort of limp it along, duct tape it together, and keep it going. And one thing I noticed that's worth bearing in mind, if the organization was trying to get to some destination endpoint, And I walked around the conference room, and the people who were running the project and were in the conference room were not themselves already running the target desired configuration. Those projects averaged 6 months slower. 6 months. And the difference is purely, I'm not scared to do it to myself. Iterative. Do it on yourself first. Deploy it to your team. Get everyone running on this. Get them living on this. Get the feeling of, gosh, we can do this. Iterative part is important. And the next thing, once we've decided on an iterative strategy, which we strongly recommend, do not pass go. Do not collect $200 until I remove admin rights from the endpoint. You're supposed to applaud at that. Look at that. And that's really just for the recording. How many of you, by way of applause, so we can capture it on the recording, already have removed admin rights from at least 70% of your users? Yeah! How many haven't? It's hard. Let's talk about that, because I'm very opinionated. Shockingly, I know everyone is very surprised that I may have a strong opinion, but I am. My opinion is it's really important that we actually remove the admin rights and not trick ourselves into thinking. Here's what I mean. If an application says I only work with admin rights, I kind of have two choices. Choice number one, fix the app. Choice number two, give it admin rights. And there is commercially available software that will do that for you, automatically elevate the software and try to protect it. And there's some controls they put in place to stop from launching, spawning new processes, so they can't spawn additional elevated XEs. You can't run some Windows commands. But nonetheless, that process is running in an administrative context, and any code running inside of it is running in administrative context, and any bugs in it will run with administrative context. And if you think about it this way, maybe you'll see it a little bit differently. You're moving, people are never actually administrators. It's software as an administrator that you happen to say belongs to you. You're moving from a world where I run all of my software as administrator to a world where I only run my oldest and worst software as administrator. Is that actually better? Arguably, I may not have moved the bar as much as I think I have. So I don't like the approach of, well, let's just go and give it admin rights, right? There are three different aspects, and really two, and one's an offspring of them, of things we need to think about. Number one, the use of admin privilege because an application demands it, the illegitimate dependency. Fix the application, whether it's get a new one or whether it's shim it up. And we'll take a look at some of the technologies that we can use to do that. The second bucket is there's a lot of organizations that struggle to get a sufficient SLA for distributing software. Developers are notorious for this, right? Oh, there's a new package that drops 2 times a week. Packaging turns them around in just 2 weeks. So we're perpetually 2.5 weeks behind on the dev tools that I need to do my job. That's my excuse to give me admin. In essence, we're crowdsourcing software distribution. I can't push it fast enough, so you just do it for me. We need to reel that in, and we need to provide that level of service. If we're not going fast enough, we need to figure out why. How do we get stuff so that we can package it up faster and distribute it to this audience so they don't have to do it themselves? And side by side with both of those is, once I start taking on managing everything, I want to start thinking about how do I make that everything group a lot smaller? Because software proliferation can be a real problem. I don't know how many software packages each of you have in your environment, and we're not going to go around the room and name it. The worst I've seen so far, I'll be curious if anyone has a bigger number, the largest number of independent software packages I've so far seen in an environment is 225 unique applications. Can anyone top that? Yes? Yeah, so we need to start trimming that down. It's hard to manage at that scale. So let's dig a little deeper into, actually before we go any further, just so we don't have anything, I'm going to turn on presenter mode, because one of the things that I've noticed about my audience is that they love to screw around with me and tweet things that will then show up with a tweet notification. So let's make sure that's turned off. In fact, let's in double pants and suspenders, we're going to go in quiet hours. I know some of you guys, I don't trust you. So, admin rights. I'm going to take an example that if you kind of followed me from back in the AppCompat days, you may have seen this before, the stock viewer shim demo. It's an application where I took a number of bugs from real customer applications and reproduced them in a way that we could distribute, right? Super common error. It checks to see whether or not you're an admin. This one, conveniently, since it's a demo, carries on and runs anyway. And if I go and try to run some additional functionality, the trends button, it's going to give me a warning. Incidentally, true story, this I copied word for word. I added the, if that wasn't helpful enough, here's some additional random hex. But other than that sentence, everything else was copied and pasted from an actual error message presented to a user, which was awesome. This is an admin dependency. Right, so that doesn't work as an admin, and these kinds of things happen all the time. Oh, I've got an access denied here, right? Things just aren't working. What can I do to resolve it? So a couple of tools I want to make sure that you're tuned into. One of them is if you download the Windows 80, sorry, not the Windows ADK. If you download the Windows ADK, there is a tool called Standard User Analyzer. I like this one better. So my friend Aaron Margosis, who will also be at the event, I think he flies in this afternoon, wrote a tool called Lua Bug Light, and it is still my go-to tool. It's distributed through his blog. So if you go find, just do a search for Lua Bug Light, 2.3 is the latest version. Here's why I like it so much. The approach to solving the problem is just architecturally beautiful. It keeps in the process two tokens, a standard user token and an elevated token. It tries all of the operations and it intercepts them to inspect, did that succeed? And if the answer is no, it tries again with the admin token. If the answer is yes, we literally just watched it fail as standard user and work as admin as the same user, so it uses UAC as its elevation construct. Very, very high reliability, right? Tons of signal, very little noise, and we can just go through and run the application. And I went ahead and ran that beforehand just so we didn't have to basically watch the same things again, and gathered some data on what it spotted going wrong. And it will go through and highlight the results. This is basically telling me these are the reasons why it needs to be an admin today and what it would take to fix it, right? In this case, it's trying to open this registry key. And if I'm the developer, I can go and see all of the call stacks. I can go and find where in my code am I doing this so I can go targeted to fix it. Very helpful for a developer. It also, if I'm not a developer, if I'm looking after the stuff that already exists, it will make recommendations. Hey, you might want to try this shim. Virtualize HKCR Lite, that might get it working. So it's actually going to guide you to how you could fix it with AppCompat shims. It notices that you did an explicit check to see whether or not you were a member of the administrators group. And it's creating a global object. Can't do that as a non-admin. And oh, here I actually needed elevation because it's an updater. Interestingly, to be clear, just kind of side note just for a moment on how UAC works. First of all, you should turn UAC on. Even as standard users turn it on, it does stuff to fix it. It also is the basis for a lot of security technologies that have been built on top of it ever since Windows Vista. Now, if you see a UAC prompt, that's not all of UAC. It's just a small part of it. But a UAC prompt never means I need admin rights. It never means that. A UAC prompt has to happen before the process launches, which means we have to try and predict it, because either the entire process has the admin token or it has a standard token. You can't, in the middle, just suddenly jump between them. So it's at launch. So how do we determine whether or not to launch you elevated? Well, one of three reasons. Either the developer asked for it, they put a bit of XML that requested it, the administrator asked for it via an app-compat shim, or technically a flag, or we think it's a setup. We added the setup logic during the beta of Windows Vista because we had the worst day in app-compat history when we enabled UAC by default on the very first beta 2 builds. Worst day. Because we went from a 93% success rate to a 21% success rate in one day. And that was because nothing installed, because they were setup.exes that were all running unelevated and trying to write to program files. So we said, let's go find all the setups. How do you find the setups? We look for the words setup, update, install, and patch. And if we find one, we're like, oh, hey, you're a setup. Let's elevate you. So this one is just, hey, it has the word update in it. So let's go ahead and prompt to open that. So relatively straightforward, right? This is how we get things elevated. Now what I've done is I've used a tool called Compatibility Administrator to build up a set of fixes, right? So here I've gone and I've applied the fixes to resolve the issues we spotted. So let's examine what they are. Force admin access. It looks like that's a force elevation tool. It's not. All this does is lie. If you've seen the American movie Ghostbusters, where they have the conversation, if someone asks if you are a god, you say yes. We've implemented that in code. Are you an admin? Yes, I am. We don't even look. We just say yes, no matter what. That's how that works, and it gets past those checks. Now, that in and of itself usually doesn't fix everything because someone wrote that code, which is probably for a reason. Local mapped object will transition you from having a global namespace object to a local namespace object, right? Cardinal rule of standard users is standard users can muck with their own stuff and not everybody else's. Admins can muck with everybody's stuff. Global is everybody's stuff, so standard users can't muck with them. This just changes the question. Can I create a global object and makes it, hey, can I create a local object? Sure, it's your space. Have at it. And then virtualize HKCR Lite. HKey class's root doesn't exist. It's a virtual registry key. It's a merge of HKey local machine / software / classes and HKey current user / software / classes. If we're trying to write, guess where we default? Local machine. Access denied, you don't write it. This just changes the question to, oh, write to current user, and it's like, oh, that's totally cool. And that's fully supported. It shows up in HKCR. We've just transitioned it to a per user COM registration. So now if I just apply that, I'll just right click install the fix. Now when I run the application, I no longer get the warning. I can see my trends. I can see the wonderful options that I don't really have any of, but no more application crashes. I've actually just gone from, hey, I was going to give this old piece of junk admin rights to, now I can just run it. Yes, it's specialist knowledge, but from a security perspective, it really is the right thing to do. Incidentally, as a compatibility person, I had to share just how amused I was by this. That the app-compat toolkit was not itself compatible with Windows. That's one for the record books. In the end, it turns out that I can, without changing the code and without granting admin rights, fix most challenges with getting to standard users. Not all of them, but most of them, and that's important. Right? So things like if I actually need to take a privilege, like SE backup, SE restore, SE load driver, then I can't fake my way through that. Right? Some other objects, some other like semaphores, mutexes, other kernel mode objects, I don't have a really way to deceive them and have them be per user. The next stage, once I've removed my admin rights, is to get to a current OS and really change my way of thinking about what I can do, because each successive release of Windows provides so much more security goodness, right? Tons of investments on the security side that we can't take advantage of if we're not running it. It turns out that code running in Windows 10 doesn't help me if I'm running on Windows 7. So I've got to figure out a way to get more agile, to start lighting these things up. How do I modernize? And that's a change in behavior, right? We need to rewrite our rule books, our playbooks for how we modernize. Because if you look at how most people went from XP to Windows 7, it was basically, oh, find all my stuff, test it all, fix the stuff that's broken, then plan my migration, start scheduling them out hundreds at a time and work my way through it. And that whole process will be roughly, on average, 18 months. With something that's updating once every 6 months, with stuff that people, by and large, really want to have. Right? I had a conversation yesterday with someone who said, oh, this exploit guard stuff is really cool and perfect for some of our scenarios. How do I get that on LTSB? You opted to not get the updates, but you want the updates. This is the conundrum. If I can take the updates and manage my risk, I want to take advantage of this stuff. It's been true for each of the releases so far. How do I start getting agile? Which means getting smarter about how I test, right? It means deploying things earlier. You know, we've talked about having an insider ring for business, so we can now start to see these things beforehand. The thing to keep in mind is I need to behave according to the actual risk that I face. Going from XP to Windows 7, on average, 21% of your applications failed. 1 in 5. So you know what? Yeah, I'd probably test a lot of stuff if 1 in 5 might break. Statistically speaking, moving from Windows 7 to Windows 10, it's right around 2%, a little less, in fact. An order of magnitude smaller, and yet we're executing the same playbook. 10 times less risk, same process. I'm over-managing to risk. When I go to Windows 8 to Windows 10, it drops to a fraction of a percent. What's the difference? Starting in Windows 8, we lie about what version of Windows we are by default. So Windows 8.1, if you ask it, what version of Windows are you? I'm Windows 8.0. Ask Windows 10, hey, what version of Windows are you? I'm Windows 8.0. Forevermore will lie by default. And in fact, you have to recompile your app with a new XML compatibility manifest saying, hey, I know all about you, Windows 10. You can tell me the truth before we tell you the truth. Literally, it's 80% to 90% of the difference in compatibility is just, hey, are you Windows 10? Yes or no? Oh, you're not? Oh, I don't know anything about Windows 7, so I'm not going to run. Nothing technically wrong. It's just acting like a petulant child. You're not my friend. And between updates, smaller still. Again, not zero. I want to make sure that I'm managing the risk that actually is there. Trust but verify, and find processes to do that. And it ain't just Windows. I've been showing this slide for the past year and a half, and there are still people who haven't heard this announcement. Java in the browser is going away. Yeah, a year ago, it was not applause, it was, oh God. What am I going to do? Middleware is another concern. What are all the dependencies that I have, and am I keeping them up to date? So I need to think holistically about how do I modernize the entire stack and understand what's there. You will notice, and there are sessions here about the upgrade analytics tools, which they've been, now I'm starting to mix up the names because we've changed them and I forget which one's the new one. But basically in Windows Analytics, we can look at information about upgrades, and that's one of the things we've been pivoting on, is understanding that chain of dependency. After I modernize, I need to think about how do I harden the OS. Now, as a starting point, and just to make sure that everyone is aware, my personal opinion is that from a group policy perspective, you shouldn't be rolling your own every time. Now, typically, if I look 5-10 years ago, right, when we first shipped a new version of Windows, have any of you seen the movie The Jerk with Steve Martin? When it's like, the new phone books are here, the new phone books are here, right? When we shipped a new version of Windows and we finally shipped that Excel spreadsheet, it was like, the new group policies are here, the new group policies are here. And then we go one by one at each of them going, what would I want for that one? And that one sounds like the best choice. That is the best policy. I am turning on that policy. Make policies great again. And what we find is that, wow, it's really crazy how much variation we'd have. Are you aware that roughly 30% of the support cases that come into Microsoft don't reproduce in a vanilla configuration? It's something about that customer's group policy configuration. Right? It's really, and if we look, and actually I've done the math, and I've got an app compat session where I'll go into more details, right? But the number of group policy configuration permutations for the browser itself exceeds the number of molecules in the observable universe. Turns out we don't have that many test cases. So one of two starting points you should have is, number one, the way we ship it. And then go through and sprinkle on some of the user-friendly stuff like, hey, I don't want my users to all have to opt in or opt out. I'm just going to choose for them so they don't ever see a dialogue. But in terms of the security settings, the way we ship it, because we try to ship it very secure, but if I have unique security needs, we ship security baselines. And we just shipped a preview of the security baseline for the fall creators update early this morning. So it's out there for you to start experimenting. Start with this and then document your variation. I know of very few organizations that don't have to document a variation, right? Even in places that are mandated to use it, like the US federal government has to use these configurations, but they all have the constraint of compatibility concerns with stuff that doesn't work. Document that, but start from here and deviate as little as you can as you go along. And this has all the documentation and all the goodies. So the security baselines is something that's really important to us, right? And we have been, very, very committed to ensuring that in the old world, right, our commitment was by the time we get to current branch for business that you would have a finalized baseline. And that's what we continue to strive for, and we're even trying to get the preview ones out there so that you can start straight away. We know it's important to you, it's important to us. Stick with known and proven solutions rather than inventing your own. Next thing is to think through, how do I start to implement some of the features? Because I can't just turn everything on. For example, Credential Guard. It's actually a relatively low risk. I want to understand the risk of turning it on. Credential Guard will use virtualization-based security to ferret away a set of my credentials. And it has some side effects. Oh, it breaks Wi-Fi? It does. Maybe if you have different authentication, it would. Yes. Yes. That's possible. It breaks, what I've noticed more often is it breaks my NTLM v1 applications. Right? Why furrow it away if you're going to spray them around in an easily reversible format anyway? There are rainbow tables for the entire space. So if you're going to spray it around, it's security by obscurity if I try and hide it away there. So we'll turn some things off, but overall the risk is pretty low. Incidentally, there are also two applications. One of them is just the installer that actually tries to grok around in LSAS memory. Why you'd have your software installation mechanisms grokking in LSAS memory is a complete mystery to me, but it has actually happened. So it's not zero risk, but that one's pretty low. What about Device Guard, though? Device Guard, you need to have a process to. And I'll refer you to a session that we have tomorrow about practical whitelisting, where we'll talk about how do we get to implementing Device Guard. There are innovations around how can I get more multi-factor, and I want to point to some new policies, because this was one of my big challenges with Windows Hello. Windows Hello was great, except I had no way of saying you have to use it. I have great policies on the smart card side. Smart card side, I'm like, yes, you can only log in with a smart card. And there are organizations that do that. We tried that at Microsoft, and it failed for us. That's really hard, because the reason why is our building badges are our smart cards. And here's what happened across all the dev teams. We'd come in, pull the smart card out, stick it in our computer, then we'd go out to lunch, leave our smart card sitting there, and then none of us could get back inside. It's hard. There's new policies now where it can start to enforce it. And if you look at the different unlock factors, I can put in a first and a second unlock factor. And in every now and then, and by every now and then I mean most of the time, we do things in group policy that I can't explain to you rationally. Like someone decided, we need to put in an order of what these credential providers are. We could give them a name, we could give them a number, we could give them a GUID. Someone thought, you know what, GUID. Who doesn't like a good GUID? I know exactly what that is. Oh, I love that D688. Oh, whatever that thing is amazing. And then we conveniently didn't actually give you the list of GUIDs in the help desk either. But with these, you can now enforce it. To unlock your device, you've got to have these two factors, and you can start to categorize them. For example, one of the policies I have set up on my device, and so far it has not completely hosed me, so I'm fingers crossed that continues to be the case, right? But the two factors I have set up are, I do PIN unlock for mine because I'm a security nerd, so I have something covering up my camera. PIN, and then either I'm on a trusted network, or if I'm not, Bluetooth connection to my phone, proximity. Right? So when I logged in, when I got into this room, the network hadn't connected yet, so it was like, oh, okay, let's look for your phone. Oh, there's your phone. All right, we'll log you in, because I was not on a trusted network. And you can configure them and enforce them. So now you can get to true multi-factor everywhere, which is something that's really important to me. Just think about the news, right? What happened this week with one of the big auditing firms? I'm sure many of you have read the news. Email, not multi-factor. The admin, not multi-factor. The ability for adversaries to crack passwords has long exceeded the ability for users to remember them. Now we've got a lever because Hello is actually very convenient. It is certificate-based, just like a smart card, and I can start to put in that enforcement. So I can start to build out that plan. I do have some infrastructure requirements. In fact, let me switch back over. And it was held up people for a while is that, hey, I've got to have Azure AD, and I don't have that yet. Now we can do it purely on-prem. Where is the on-prem list? Oh, did I skip past it? I rolled too quickly. On-prem, which has a set of requirements. Basically, the big one is I need to have Server 2016 ADFS with a particular KB update. I can do this all internally now. I don't need to connect to Azure AD if I'm disconnected. So a lot of scenarios where the cloud and Azure AD didn't work are now lit up. So I can start moving down that line of simple, straightforward, and gaining the benefit of multi-factor brought to me by the platform. I also can start looking at internally ways to better defend myself. So Defender ATP, this is sort of an interesting bit of learning for us. Defender ATP is built upon a feature we called telemetry. We built it for Windows 7, and the intent was to understand things like, hey, if we're going to deprecate an API, how many people are using it? We couldn't see that before. So we could instrument it and just get pure raw hit counts. You hit this API this number of times, so if it's a really hot API, like, oh, let's not deprecate that, right? Lots of people are using this. Or no one's called this on planet Earth in 13 months. So great candidate to pull it out and reduce some surface area. And it was kind of one of those what's in it for us kind of things. Like, hey, you can turn on telemetry. It's a bunch of little bits and bytes that are really hard to explain because it's pure, raw, low-level data optimized for performance. And send it all to us, and maybe you'll get a better product someday. How many people do you think signed up for that? 5% of enterprise customers. The other 95% said, no thanks. I'll let the consumers do that. So we've got great data on consumers. So that took us back to the drawing board. Here's a great technology. It's running all the time. Windows passes the perf gates with telemetry enabled. So it's not a bolt onto the side thing that's going to kill the perf. It's, hey, it's already running. You just choose whether to submit it or not. What if we said, hey, this is not about us. What if we make it about you? Upgrade Analytics is all about you. Defender ATP. Hey, launching a process, in-memory stuff. In-memory malware is hard to spot, but if you're instrumenting the execution of processes, you can spot in-memory malware. Take the technology and repurpose it to something that you want. And now you're like, yeah, you know what, take this data, and you process it and give me useful information? Awesome. I'll take some of that. You process it and maybe fix my bug, but no promise, no guarantees? That's a lot of risk for not a lot of payoff. So thinking about how do I build my plan to turn features on. I also want to think about the browser, and I'm going to talk about the red-headed stepchild browser of the world, and don't think I don't know it. But I at least want people making a sound decision on what their strategy is. The choice that ideally wouldn't have you make as your primary browser is IE. Not because it's bad, but because it's now completely stationary. IE is now thought of internally at Microsoft as a compatibility solution. We are not adding any new features. As the web evolves, that browser does not. Today, it's kind of close enough for most websites. But 2, 3, 4, 5 years down the line, that becomes a problem. You start to lose compatibility with public sites. We've seen that before. I remember the day when Office 365 announced we are no longer going to support Internet Explorer 8 on Office 365 so we can go big on HTML5. And the enterprise customers around the world collectively gasped, what? I planned on holding on to IE8 until 2020. But it is a stagnant compatibility product. Same thing here. Don't make that choice, ideally. For compatibility, yes. And so we've been focused on building a way to duck back for compatibility, right, with the enterprise mode site list. Flag a site, pushes back into IE, and you can even have IE push you back to Edge for everything else. Similarly, other browsers will have other fallback technologies that can have a list to point you back to IE, where Edge has been innovating, and it's certainly worth looking at just as a security engineer, the kinds of protections we're doing. Just like Chrome is worth doing, because we both have a slightly different viewpoint, and we're both doing great stuff. We're really optimizing for how do we protect memory, how do we do the isolation, and turning on all of these features. So, you know, even as a case study for how do I get my software hardened to the maximum possible extent, following what Edge is doing and following the blogs about that can be really valuable. So getting the right browser strategy to stay modern there. And the next step, kind of dovetailing on that conversation, is how do I make better software? Because if the platform becomes hardened enough, then the soft underbelly becomes your software layer. So I need to get better at writing secure software. We have all sorts of processes around that. We call it SDL, or the Secure Development Lifecycle, that really walks you through end to end. How do I design things securely? How do I implement them securely? Verify the security of them. And we've published this as broadly as we can. There's websites on MSDN about the SDL process. There are books. Michael Howard, who wrote the book Writing Secure Code and wrote the book about SDL, also consults directly with our enterprise customers to teach them how to do that. Worked on things like the Olympics website that we stood up to make sure that it was as secure as it could be. We need to address that. In the light of last week's compromise of CCleaner, or CC Cleaner, I don't remember which it is, right? CC Cleaner. That was a dev workstation. We'll talk about other defenses for that, but we had a process that didn't verify things through to the end. We just trusted what was checked in. So we need to update that process. It's something that we take really seriously in terms of our dev processes and want to evangelize. We want to give this away. I can retroactively add protections that are built into Windows using Windows Defender Exploit Guard, which has more than just these memory protections. There are other things that are going to be covered in a session this afternoon, which I would encourage you to attend, that talk about things like attack surface reduction and protected folders and all of the other investments we've been making. This is specific to defending the software layer, but it's a multi-layered platform to help make a more secure endpoint. And as I complete the circle, I inevitably get to application whitelisting. Yay! And there was one rejoicing. This is easily the biggest pivot we've had since transitioning from a world where everyone's an admin to a world where no one's an admin. In fact, it may be bigger. This is transitioning from everything is trusted until it proves itself to be bad. That's the legacy antivirus approach. And pivoting and saying, no, actually, I'm going to assume everything is bad until it proves to me that it's good. A complete shift in how we think about software. And the recommendation I have is to not think about it as one defined thing. Not just one thing, but instead to think in tiers. It's not black or white. I'm either whitelisting and getting down to exactly what runs, or I'm doing nothing. That tends to be hard. Getting to a pure whitelist of everything, how realistic is that really? What we know from people who do migration projects to the latest version of Windows is step one, let's figure out what we even have running, because I don't know. And if you don't know, how can you whitelist it? So the approach that I would recommend is 3 tiers. Tier 1, what if I just, you can think of it as either blacklisting a user-writable area or whitelisting the admin-writable area. It's a technique that was originally pioneered, at least to my understanding, at NATO, but that was taken up by the NSA. They published a white paper on it. And then we've taken it, and we've been trying to automate that. My friend Aaron Margosas has been doing that, and we'll be showing some of our progress on that so far tomorrow, if you want to get more details on doing that. The concept is this. If an admin puts it there, it's okay. The user puts it there, I'm not going to run it. That way, anything an admin put, whether it's manual, right, desk side, walk up, type it in, get it in there, that's good. Oh, they download it from the web and they try to run it? Nope, I'm not going to do that. Obviously, with some exceptions, because there are some software that I do want to run that comes sourced from the web. OneDrive sits in a user-writable area. Teams sits in a user-writable area. WebEx has executable code in the user-writable area. Chrome can be installed in a user-writable area, but can also be installed in an admin-protected area. But the Pepper Flash player sticks in the user-writable area. So we have to discover those too. That's why automation scripts become important. But once I define that, now I can just say, yeah, whatever it gets put on there is okay. At least we're protecting from the drive-by stuff and the user deciding to hose themselves stuff. That changes the game enormously. One customer observed an 85% decline in malware activity in their environment after doing this. Not perfect, but a great, that's your low water mark, that's a pretty good low water mark. Then we get into Device Guard, and there are 2 different ways to use Device Guard, and we'll talk through these also in more detail in the whitelisting session. Right, one way, which is the managed installer option, which requires 1703. Another example of if I can keep up to date, I get more security goodies. Managed installer just says anything this installer drops down is okay. So if I use config manager and it drops it down, it'll be flagged as it gets laid down, and then it'll just be approved. If an admin walks up to the desktop, logs in, and tries to install it, doesn't have that tag, not going to run. Next layer up. Should get you thinking, my goodness, I should really protect my configuration manager administrators, because now they can unlock everything and get past the whitelist and all that. Next tier up is the pure whitelist. Here is the software that can run, which today is pragmatically probably mostly used in scenarios like a point-of-sale system, kiosk, ATM, ticket machines. Although ticket machines, to my experience, don't tend to be running Windows 10. As evidence, if anyone follows me on Twitter, I'm at AppCompatGuy on Twitter. I posted one of my most retweeted tweets ever, which was a picture of the MetroCard dispenser in New York City that had been rebooted and was rebooting and showing me the Windows 2000 boot up screen. Fortunately, New York City is a very sparsely populated small town with very few criminals and very little criminal activity, so I'm sure that's fine. I had no problem putting my credit card in there. So we complete our journey, and then we begin the next iteration. I'm going to remove more admin rights from the next round. I'm going to get more people deployed to the current version of Win 10. I'm going to continue to harden it, light up more features, get the next round, explore, prototype, continue to work with my software developers, continue to raise my standards on the third parties that are selling me software, demand that they not sell me crap software anymore, and put in quality gates based on measurable data. You did this, it cost me this much, right? Either you discount that amount that it cost me, or you meet this new quality bar. Don't set them arbitrary, but set quantified quality standards and then continue to pivot towards trusting by exception. That gives us the secure foundation. With the secure foundation, we need to make sure we have the ability to support it securely. And the help desk scenario is one that, to me, we haven't really taken on yet. So if you're a bad guy and you want to get privilege in an environment, what's the single most common way people do help desk? Oh, welcome to the help desk. You are added to the company/help desk group, which is a member of the local administrators group on every single endpoint in the environment, and maybe some servers also, just basically everywhere. You have privilege everywhere. How will you exploit that? Well, you just get on an endpoint, make it act up until help desk connects, grab their creds, and now you're an admin everywhere. Hooray! You just won. Now, fortunately, in most organizations I work with, help desk tech is the next promotion after CISO. So these are your oldest, most senior, highly security. Hold on, I'm being told that's actually not true. These are the people you know the least, and they have privilege everywhere. How do you solve that, right? The attack vector is relatively straightforward. I just pop on your device, make that up, wait for you to connect, and boom, I can start moving around the environment. Party on Wayne, party on Garth. And problems ensue. And so we think about, how are people solving this? And we have huge conversations on this. One proposed solution is, I can have my help desk always connect in with the restricted admin switch in remote desktop, remote assistance. The fatal flaw that we found with this one is this only works if you are network connected. And in our explorations, we found that roughly 50% of all help desk calls are in a, I can't get on the network, I'm in a hotel, I'm not on the network, you can't connect to me that way scenario. And if I can't log in, this doesn't work. Okay, great, back to the drawing. I need something that actually works. So then we said, well, Laps, right? Laps is solving the problem of everyone has the same admin password everywhere by randomizing it and, escrowing it away into Active Directory. A great solution. But if I give everyone access to that, then if I grab the help desk user's credentials, I may not be able to immediately go and log in, but I can go and read off of the directory and grab all of the attributes for everybody else. It's not one-to-one, it remains one to everybody. It's still a high-value credential. I could buy a cred vault and go one by one and check them out. And I actually really like that. But by and large, the response I get is, I'm not paying for that. Every endpoint, they charge per device. So then I thought, how could I solve that? So I cooked up a prototype of what I think we could and should do. And I want to show you that prototype. Oh, you missed the additional factor. I just phone off me. That was so, I love that stuff. All right. So in order to mock up a simulation, I've actually not installed labs and servers and all of that, right? I want to do it all locally. So what I've done is I've just stuck this away in a registry key, right? So I'm HKey local machine, software, CJAX, laps. And it's a reg key. And what I'm going to do is I'm going to deny me access to read the contents of that registry key. I can't get there, right? So think of it like laps, the protected attribute. It's protected. I'm not going to be authorized to do that. And what I'm going to use as a tool to simplify this is another PowerShell construct called JIA, or Just Enough Administration. By way of round of applause, so we can get it onto the recording, how many of you have heard of JIA? How many of you love it? Oh, I'm going to change your mind. So the concept of JIA is this. PowerShell has the notion of a remoting endpoint. JIA is whitelisting for your endpoints. You liked whitelisting. Why wouldn't you like it for PowerShell? What I'm going to do is I'm going to enter PS session. I'm going to connect to myself. I'm just going to loop back to me. And I'm going to go in with a separate configuration called help desk. And that's going to connect me to a JIA endpoint. Now, normally if I connect to a PowerShell remoting endpoint, I'll get all of the PowerShell stuff that I'm able to do. What JIA does is it lets me say, nope, these are the only things you can do. And that's it. And what I've done is I've written two simple PowerShell functions. Get laps password, and I'm going to take it for computer 1. Be like, oh, here's the password. Knowing how much all of you guys love GUIDs, I stuck a GUID in there. So here's a password that's checked out to me. Since I have PowerShell sitting in between, I can start to enforce rules. The two rules I've heard requested so far are, number one at a time. It's one-on-one admin. I should not be able to check them all out. Don't give me all of the things, give me one of the things. Rule number 2, make sure there's a valid help desk ticket open. Do not just give you admin rights on whatever device you want to, otherwise you'll be like, oh, Satya N/laptop. Let me go ahead and connect to that one. No help desk ticket, no admin, right? Further controls. So if I then try to do get laps password computer 2, it's going to be like, nope, check your other one in first. So I go, oh, yeah, sorry, whoops, I forgot. Set laps password computer 1. Now it's back in. Now I can get it for computer 2, and it will hand it to me. So I can start to gate that and move towards one-to-one. This is a prototype. This is something that we're actively working on. How can we provide this kind of one-to-one admin functionality? But that's the kind of thinking we need to have. That's the next threat vector. I've taken out my actual admins, but I've ignored one because they've kind of flown under the radar. I need to address it. So let me go ahead and check this back in. Now it's put back in, and exit PS session. And I'm done. Now I can go and do my work, do one-to-one admin, get local privilege, and have it be one at a time. What do you think? Like the idea? Should we keep going? They can't hear you on the recording. It's all about the recording. It's not about me. I see you smiling, but they can't. So secure support, super important. We also need to think about how do we handle high-value assets. The most critical things I have in the environment, whether they be my local administrators, my system administrators, my domain administrators, people who are operating mission-critical systems. And as we found out last week, much to our chagrin, my developers. Because if I'm producing software, that's a big risk for me, to have vulnerabilities injected into the software that the adversary can come back and later compromise. The academic background is, in essence, we want to make sure that we're never reaching out of our trust zone from a device, right? Ends up being a really important construct. So I protect the device, but I want to go into the specifics of what the real danger is, what I want to protect against. Now, it's pretty simple if I think of a device. If I take my laptop and I go surfing to the kind of sites that may have an adversary, whether on purpose or because of a typo. That happens a lot, right? The typo squatting is a thing. Somehow, I click on the wrong email, right? The dancing pigs are too tempting even for me. I follow them. There's a risk. You get a photo of my device. Now they're on my device. They grab the things on the device or everything I have access to, right? Relatively straightforward. Now, one of the proposed solutions I hear a lot is, okay, no problem. We'll just put in our jump server. The jump server will inoculate it, just like in the 80s, right? You just go do whatever you want to, go get some penicillin, and everything's fine, right? Rock stars from the 80s. Turns out that didn't really work, and it doesn't work here. What's the real threat? And the real threat is that that doesn't give me the ability to be inoculated. So let me go ahead and, well, I've set up a jump server for myself. Let's go ahead and connect to it. Yes. All right. Oh, whoop. You know what I didn't want to do? I didn't mean to go full screen. Here, let's disconnect. And we'll edit the connection, and let's make it a smaller thing. Let's go to display. Let's go down to maybe that. That'll be a good one. All right, so I'm connecting to my jump server, and I'm like, oh, I'm all hunky-dory. I'm happy. I can do secure administration here, and everything's going to be just fine. Right, so I'm connected in, and I'm going to go and do my work, and it's inoculated, so nothing bad is going to happen here. I'm going to have my little, oh, I've got some updates to do. That's pretty awesome. My power, command prompt window open. Let's make that a little bigger. So properties. Let's do that. 18 point. Is that big enough? Can you guys see that? Nope, that's not big enough. Let's make it bigger. It's probably too big. There, that's good. So I'm doing some work. Everything's okay. This is and I've got it locked down, whitelisted, like nothing's getting on here. What's the threat vector? The threat vector is that if I'm coming from an untrusted device, they can drive that window for you. Now, most adversaries are not polite enough to give you an optional window with a pwn button on it that you have to click. But word of warning, if that ever does come up, don't click the pwn button. But it's going to start sending keyboard commands. Look, no hands on the keyboard. It's typing. Oh, it had an admin. Oh, that's convinced successfully. And because they're a smart adversary, they're going to notice, oh, you could probably see that. Let's clean that up. Done. Now, one of two responses I get from seeing that. One person's like, I'm going to notice them doing that. Do you know how to stop you from noticing them doing that? You take a screenshot. Create a window, set the screenshot as the image in that window, and now it looks like your remote desktop window has frozen temporarily. That never strikes anybody as odd. In fact, if it didn't pause for a moment, that would strike them as odd. Put it in there, do your dirty work, clean up, make the window go away, and you have no idea. You just think it froze for a minute. You got multi-factor on that jump server? No problem. I'll just wait for it to show up. I can poll on that window. Oh, the window showed up. Send an alert. I cannot inoculate myself with the jump server. I've got to protect through the keyboard. So the first reaction is to poke the holes in it, right? And there aren't holes in it, right? You can protect it. The second reaction is my absolute favorite. I showed someone whose plan was to put their jump servers in Azure, and of course, usually at Microsoft, you say Azure, and everyone's like, yes, that's the right answer. And I'm like, still not the right. You got to have a trusted keyboard. Endpoint matters. And I showed him the compromise. And he looks at the compromise, and he looks at me, and he looks at the compromise, and he's like, but I don't want that to be true. So I can't inoculate at the endpoint. That's why we've been investing in building hardened endpoints. The gestalt is that we need to have a chain of trust that extends from the keyboard all the way to the asset. That means I'm not even going to trust the firmware. I'm not going to trust my downloads to flash the firmware. I'm going to do them multiple times. I'm going to use a whole process to validate and make sure that I have as much trust as I possibly can in the endpoint. All the way through. If I'm managing tier 1 assets, I trust from tier 1, from the keyboard to the jump server to the asset at the end. Now, from an implementation perspective, we want to use all of the stuff we've just talked about. We're just going to turn it up to 11. Because you don't need general purpose software to run. You don't want it to run. I can get to pure whitelisting. This is one of the scenarios that it's perfect for. And if I think about how I do the devices, we also need to overcome, hey, how am I thinking about this device? Right? The legacy way of thinking about it is I'm going to have 2 of them. Right? How many of you have budget to buy everyone who administers anything or does anything secure as many laptops as they have roles? Right? The answer is nobody. Right? I work at Microsoft, a technology company, and good luck trying to get a device more than once every 3 years, let alone multiple devices as I need them. For a few targeted scenarios, yeah, like if I'm domain admin, I'm going to carry on a second device because I don't want to have to loosen the restrictions on the root partition in order to allow you to do some of the virtualization things. But when it comes to tier 1, tier 2, high value, right, it can either be, hey, do my privilege work in the root partition and then do my productivity work in a child, or hey, just do my privilege work there and have a remote desktop client and do my productivity work in a data center. This one tends to fall down as soon as you hop onto an airplane. And that's why this is the architecture we've converged on as Microsoft. And earlier this week, there was a presentation by Jane that talked about what the Windows Server team is doing to make these PAWs broadly available for us to do the work. Because in the past, originally, you would call the services organization within Microsoft and say, hey, come build me a PAW. We'd be like, great, we'll come out there, we'll build it, we'll show you how to do it, right? Then you can carry on making as many more as you want to. And then we say, this is super important. We don't want you to have to call us, right? I mean, if you're strapped for resources, you can still call us. We'll take your call. We'll help you out. But if you got the time and the resources, we published our recipe. And now the server team is going to just build it for you. And this is the architecture to use. A root partition that does nothing but launch other stuff, whether it be a local productivity VM, a local tier 1 trusted workbench, remote connections to other things, right? And start to pair that with some of the things going on in Project Honolulu, PowerShell, and Gia, right? These all come together to simplify. As we move away from a GUI world, in a GUI world, I have to build more virtual PAWs because I don't want to be sticking in my secure workstation the administrative tools that have a hard dependency on Java 1.6 update 22. That messes it up for everything else. So now I've got to build a separate PAW virtual device for that scenario. As soon as I converge and everything's PowerShell and remoting and all this endpoint, I can simplify, right? So I've got a process of now, make more, and then gradually retire them until I get down to everything is pumping through whatever Project Honolulu gets called, which is going to expose remote desktop and PowerShell and the web UI is where it's going. This is the architecture that allows us to support that and scale up and scale down to meet the needs of what we are faced with and working with today. Because the scenarios that we put on there, Throwing it all together, the super paw, puts you at risk. Scenario paws, separating them out when you need a security division is what makes things work, whether you put them on a jump server or put them locally. Having those hardened workstations, whether they be for your administrators, for your developers. So in Microsoft, we call them SAWs, Secure Account Workstations, Secure Admin Workstations. Right? SAW, lawyers don't let us call it SAW publicly, though I guess I just did. But I'm telling you what we do, so that's okay. And we call SDW, Secure Developer Workstations, that our developers use to write code. Right? You want to talk about, well, first of all, as a developer, I can say fairly, right? Developers are kind of a pain in the butt. Don't want to move. Hey, you're not supposed to clap to that one. But it's true, right? But that was a big transition for us. So that's our roadmap. And before we sort of duck on, right, one thing I skipped over that I wanted to point out, because I think it drills home an important point, that little exploit, do you want to know how much code that took? Here's the source code for it. It took me 262 lines of code. That is it, to compromise that configuration. Don't bet the security of your company on something that someone as incompetent as me can compromise in 262 lines of code is the big recommendation here. But that's our roadmap. We can move from wherever we are and think iteratively, how do we build the right devices, how do we support them, and how do we special purpose a subset of them because of their unique needs to raise the bar. Right? We live in a different world today. The security context is different. Think about how different the world is even since I was a kid. When I was a kid, right, what would my mother tell me? Don't talk to strangers. For God's sake, don't get into a car with strangers. Be careful with people you meet on the internet and all of that. That was the world I grew up in. Where do we live now? Now we get on the internet to summon a stranger to drive us around in their car. It's a different world. We need to move the bar, and we need to think aggressively, because in the end, we're being chased by a bear. But the reality is, you don't have to run faster than the bear. You just have to run faster than your friends. So with that, I wish you the best of luck in your security initiatives as we together work to secure the endpoint. Thank you very much.